Hello, everybody. Hope you guys are having a good day. We are going to start off by practicing circumference, and then we're going to add a little bit to the circumference today to find arc length. So we're still going to build on what we were doing yesterday. So take a minute and answer these review questions from yesterday's Edpuzzle. All right, so we are going to be talking about arc length, and I'm just going to give you guys this formula, and basically it is going to be the circumference. You'll notice 2 pi r over here is the circumference, and then it's going to be like a piece of the pie, the measure of a circle of the degree divided by 360, okay? And the best example of it is this one right here. So going to pull up my other screen here. So we're basically going to be looking for some part of the circle. And there are 2 different types. This one is called a major arc, which means it's a bigger part of the circle. Okay. And this one right here is called a minor arc because it's the smaller part of the circle. Now you'll notice that every circle has both. So even though this green is the major arc, it still does have a minor arc, okay? And just because this pink is the minor arc, it still does have a major arc. So you're going to have to pay attention to what it's asking you for. Is it asking you for the bigger arc or the smaller arc? Basically, that's what major and minor are. And then we also want to focus on the fact that our formula is either 2 pi r times the degree over 360 or diameter times pi degree over 360. Okay. Obviously, yesterday we talked about in circumference that we would either use the radius formula if we had a radius or the diameter formula if we had the diameter. So that's why either one of those could change. All right. So we're going to work through a few examples of this. Okay. And on most of these, it's asking specifically for either the major or the minor. So you don't have to do any guesswork. Okay. So let me pull up. I'm going to zoom in just a little bit. So the first thing you should notice is, do we have a diameter or do we have a radius so that we can tell which one of our formulas that we're going to use? So we do know that we have a radius. Remember, a radius is halfway across the circle. So that means we are going to use this formula, 2 pi r, okay? And then it's going to be degree over 360. That's how we're going to do it. And it's asking us for the minor arc, which is this small piece right here, okay? And it is telling us that this degree right in here is 90 degrees, okay? 90 degrees in there. I guess there probably should have been an arrow, okay? So now it's literally just a matter of plugging in and solving. So we're going to replace pi with 3.14. We're going to replace r with 20. We're going to replace the degree with 90. And then it literally is a multiplication problem, okay? And if you have a calculator that has parentheses, you can do this all at one time. So on mine, I'm going to say 2 parentheses 3.14 parentheses 20 parentheses 90 divided by 360. Okay, I don't know if you can see that I typed it all in there. I hit enter, and it tells me that my answer is 31.4 meters. And so that, sorry, I probably should zoom out a little bit, 31.4 meters, that's how big this little pink section of our circumference is. Okay, we're just looking for that small little section. Okay, so let's work on another one. All right. So for this one again, it shows us that we have a radius it shows us that we're looking at this arc right here, this minor arc right here. So let me pull this one up. We're working on this section right here. We're again going to use 2 times 3.14 times the radius of 3 times the degree over 360. Okay, this part, and 360 do not change. The only thing that changes is these two numbers right here. Okay, so we're going to type that back into our calculator. 2 times 3.14 times 3 times 120 over 360, and you should get 6.28 inches, which tells you that this distance right here is 6.28 inches. Okay? All right, we're going to do another one of this. And the first thing you should notice is that this is a diameter, which means we are going to use a different formula. Okay, so I'm going to start off by writing down that formula first. It's the diameter times pi, right? And then degrees over 360. So we should know that it's asking us for the major arc, which tells us that it wants us to have this much right here. So when it asks you for something that's not listed, you have to do a little bit of work on this. For example, we know that a whole circle is 360 degrees. And we know that this portion of the circle that we don't need is 67 degrees. So we have to subtract to be able to get the amount of degrees that we're actually going to be talking about. And in this case, it is 293. We also know that our diameter is 10. And so now we're just going to plug into our formula. So we're going to replace diameter with 10, 3.14 for pi, and degrees is going to now be this 293 over 360, okay? Because it's asking us for the part of the circle that was not listed. That's why we subtract from 360. So now again, it's just a calculator problem. 293 divided by 360, and you end up getting 25.56, and it would be centimeters. So this much of the circle is 25.56. Okay, let's look at another one. All right, so this one again is asking us for a major arc. Okay, and so again, we're going to have to take what we have and subtract it from 360 to find the degree that is left. So again, it's asking us for this part of the circle. Okay, we do have a radius here, so that means we're going to go back to using 2 times 3.14 times r, right? And then degree over 360. So we're going to replace 8 with this, but first I would subtract 135 from 360 to find out how many degrees we have, and we have 225 is what we're looking at. So now it's just a matter of putting it into the right places. So 2 times 3.14 times 8 times 225 over 360. Again, it's just a calculator problem. We're going to multiply it straight across. And you should get 31.4 yards. Okay? So hopefully you can notice the difference between when it's asked us for the measure that's given versus when it asks us for the measure that's not given. Those are the ones you're going to have to subtract out to find. But other than that, your formulas are exactly the same. Okay, exactly the same. So you're going to do a practice problem of both of these. So we're going to start first by just finding the minor arc. So let me make it bigger for you. You're going to find the minor arc, which is the arc that is given. So go ahead and plug this into your calculator and see what you come up with. All right, and now you are going to find the major arc. So this is where you need to subtract from 360 to find out what part of the circle is left, and then plug it into your equation. When you're finished with this, get started on your exit ticket, and then let me know if you have any questions. Have a good day.